like do the contract that we started yesterday in the last minutes, and you may try like to code it by yourself. If you're not comfortable with that, I can code myself and you follow along. Maybe we can do something different later. Up to you. How do you guys feel about the lesson of yesterday? You want me to go? Raise your hands if you want to go along. Like, okay. Go along. I mean, like I code and I explain whatever I do. Okay, let's do that way. Maybe we can do some exercise later. Okay. Okay. So yesterday we installed Foundry. So I'm going to I'm going to what was the folder? It's in project lscd Urbe campus. Okay, and so we started coding the basics of a crowdfunding project. Sorry, also takes a while to open up from BSL. Let's retry. Okay. So we initialized the project yesterday, and the very first thing that Foundry init does, it initialize those files which are the test and the scripts. Oh yeah, sure. Okay. Oh yeah, destra sarà questo. Okay. Maybe a little bigger. No, ancora no. Facciamo una piattaforma dove si usano gli we do a platform in which we use RC20, but we are doing like Kickstarter platform. So there is someone describing a goal that you want to reach, and people can donate to fulfill like the milestone, like in Kickstarter or crowdfunding. It's just a simple project, but it showcases more or less all that we spoke about yesterday. Sorry. RC? Possiamo. Yeah. Se facciamo in tempo, sì, assolutamente.
Oppure anche solo come si legge.
Sì. Sure. So, first thing first, whenever you start a project, you want to either like comment out stuff in here, because these are auto-generated. You can even either delete these or just comment out. Otherwise, when you are compiling, Foundry looks in all of these three folders. So it's a good way to platform. Yeah. Okay, so yesterday we had a look at we were starting to doing the first function that we want to make. So if we are like the publisher of a campaign, the first thing that we need to do is to actually create a campaign. And in order to do so, we described what a campaign is and what are the like the attributes that we put in. And we wrote these two mappings that one is a mapping that links the ID of a campaign to the struct campaign, and the other one is like a contributor mapped to amount contributed. This is actually wrong because we need to make nested mapping as we did yesterday. I was in hurry and just mistyped. So the first thing that we want to create as a variable is a counter, because we need to take tracks of ID and increment the ID each time. And we just can declare counter. It will start as a default, so that's 0. That's 0. And the first thing that we can do in here is actually taking the counter and the increment. So operators in Solidity for this kind of operation can be used in few different ways. We can of course write counter, and we can either like plus equals 1, but we can also write plus plus counter or counter plus plus. This just increments the counter. So the first thing that we want to do is like avoid using ID 0. So we either like initialize counter as 1, or we just increment before doing the logic. Pretty simple. So the first thing that we want to do now is to create a campaign. So we can initialize a new object campaign, and we can use directly the mapping in here, and yep. So we can just write as campaign at ID counter, which in this case, if that's the first one, will be 1, will be equal to the name of the struct, the type of the struct basically, and we can add new campaign and write in the parentheses all the attributes that it contains. So the creator will be message.sender, and sorry, can I make it like that? Do you all read? Okay. Okay, so the creator, we can, a good practice in here is to add like underscore before this one, so we don't get confused. So title is going to be title, description, nope, description is going to be description, and what else? Goal. It's going to be goal. Then we set the expiration date as called. Okay, expiration date will be the expiration date. This, as I told you yesterday, is a Unix timestamp in seconds, but so from the front end, when you will work with that, Mattia, I think the next teacher will figure out the way. You just need to not use directly Unix if it is in milliseconds. Keep in mind we need to use seconds, and the amount raised. The amount raised for now should be like not null, but we don't set this because there is no amount raised yet. So amount raised is equal to 0. And the status, the status active, completed, failed. Okay, we can use this enum that we did yesterday. So campaign status will be campaign status like dot active, and this stands for 0. I mean, Solidity will interpret this at 0 in the. We use active just to make it more clear in here. That's the goal of enumeration. And I think we pretty much did all. Okay. Whenever you are writing code in Foundry, you should, if you downloaded like the extension, you should be fine, I guess. Let me just delete these 2 files for now. We can like run forge build to compile the contract. So whenever you are writing the contract, if you want to check that everything is fine and it's compiling well, you can just run forge build. And oops. Okay, now it's telling us some error in here. The error is that I used new, which is not correct, I guess. And indeed, now campaign status. Oops. Okay. That's campaign status. Match from declaration. Yeah, I guess.
That should be just status.
It's.
When we declare the.
Huh?
When we declare the object on the left, should be just status, not campaign status, which is the type.
Yeah, like it's status. Yep. Okay, so everything is correct, and if it doesn't show any error, the code is compiled. And okay, Foundry is pretty much fast, and errors are much explicative. So in that case, good catch, by the way, that was the mistake. So now we created this option, this campaign, and what else we can do? Like for example, we need. No, wait a second. We haven't set like a minimum amount. I guess what's the goal? Okay. Yep. So that one is useless because the goal is the minimum target that we need to make so that the campaign owner can actually withdraw. So now that we have this simple function, anyone is able to call from outside using TypeScript or even from here in Foundry. We will be able to call this function to create a campaign. So the next thing that we want to do is that we may want to have a function to deposit from a given campaign. So what we can do now is function. How can I call that? Contribute. And function contribute is going to be is going to take an argument of int campaign ID, and we can describe now. We can decide how much we want to input as how much we want to put in. So amount in, and we can call this public because anyone is, or even external, because everyone will be able to call this function. And the first thing that we can do in here right now is to make sure that the campaign exists. Oops. So because we are using mappings, each of these campaign actually exists. So if I try to access the number 1 or 2 or 3, they all exist and point to a campaign that is defaulted to default values. So we may create an error. Generally speaking, like in the usual standard for writing contracts is not a rule. It doesn't really change the behavior of the code, but you generally like have errors and events on top or into a different interface. And so we can you can either like create an interface in here, like interface crowdfunding platform, or you can just create a new file, maybe in a folder with interfaces, and creating that in that way. So for now, we can just create this interface, and we can create an error named campaign doesn't exist, and we may actually add an index or the ID of the campaign ID. And once we declare this one, we can go in contribute and write what we can do is that now we can write as campaigns. Was it? Okay, as campaigns, and we pass in the campaign ID from the argument, of course. And in this case, we have a few things that we can do. Yesterday, we had a look at the notation memory for strings or structs and bytes and other things. So what we can do now is that if we have this object, we can directly read that and create a new object that is in memory. Because this one, if we now create, let's say, object campaign 1, the campaign 1 will be actually in the storage. It will be accessible from everywhere. So we can write campaign, which is campaign memory, and we could call that campaign just that way, and that will be equal to as campaigns campaign. Oh, sorry, okay. Campaigns campaign ID. Okay, so this means that this is accessing directly the storage. So we are reading from the storage, but we are initializing an object in with the memory notation. If we do that way, it means that now this object here is the same as the one in the storage that we read, but we are not modifying anything in the storage because campaign is initialized as memory right now. So to make a quick example now, if let's say if we add some value into this campaign, for example, we would increment the amount raised, for example. So we could like write campaign amount raised plus equals amount in. And if we now let the function that way, this won't take effect because we basically copied what is in the storage into memory. But as soon as the transaction is executed, the memory gets deleted, basically. So this is not a way to save a mapping as something in the storage using structs. If we want to initialize memory because we want to do a lot of operation on this object and save some gas, because memory is cheaper, as I told you yesterday, we would at the end write that as campaign ID is equal to campaign. So that way, in that way, we are storing effectively what were the modification that we made to the object campaign to the storage. Another way to do this this kind of thing, which may be easier but more expensive if you do a lot of operation, is to declare this as storage. So we are now effectively like dealing exactly with the storage object as campaign at this ID, and we could do the same thing basically. So in that case, I could end my function in here, and the amount raised will be effectively changed in the storage. So there are two kind of things to do that way. So in that case, since just to tell you the difference in here, each time the solidity, each time the AVM tries to read on the storage, this has a cost, and writing directly on the storage has even more. So basically, this way might be the faster, but it can be the slower one if you are happen to do a lot of modification to this object. So the general rule is that you work on memory and then push it to the storage, basically. So sorry for who is writing this, but I'm reverting to that kind of setup in here because it makes more sense. So a user would like contribute and he would put some amount in, but I think yesterday we wrote the mapping that I deleted. In that case, we also need to keep track of how much each user is funding for each campaign. So we can do a nested mapping as we saw yesterday. To do so, to refresh your memory, it's like we map a new int campaign ID, and inside that we have another mapping. So we write again mapping. We open the parentheses and we type the address funder, I guess, mapped to the uint amount. So this is public amount contributed Okay. Pretty clear, no? So by doing so, we will have a function to which we can pass campaign ID and the address of the user to retrieve what is the amount that he put it in. So of course now we can oops, sorry. Okay. What I was about to do. Okay. Of course, now we need to write how much he has been putting in. So we can write as amount contributed and use campaign ID, and we can use message.sender because the user is probably going to call this directly. Like if you tomorrow or in 2 days, I don't remember, you are going to do a simple front end to interact with this app, you are going to be the message sender when you call this function. So it's pretty straightforward, and this will be equal plus equal the amount in. Okay. So one thing that we want to do now, what do we miss in here? We miss actual money, something to send in. We don't want to just update some value, but we need somehow to send some value into this contract. So what we haven't done yet is to initialize an ERC20 token as we saw yesterday. And in order to do so, let's see, why do we have this one? Okay. We can import the interface of the ERC20 token. And I'm not sure if you guys are up to date with the remappings that I made yesterday. Everyone has installed the OpenZeppelin folder yesterday. Okay. All right. So once we have this ERC token, something that we want to do is to let the contract know what is the token that we want to use. Let's say that we want to use USDC for this particular contract. So USDC is like a one-to-one token backed by dollars. So there are many stable coins in this space. The stable coins are generally tokens that are one-to-one with the currency that they describe. So in that case, what we want to do is to declare this interface. We can use this as either internal or public, doesn't really matter. We can do that as public for now. And we can call this USDC. So we are declaring this as USDC, and if we want to use, we need to first figure out what chain we are working on. So if I think you got funds for Base Sepolia. Mm-hmm. So if you need to find the address of USDC, you can simply type USDC token address. I guess there should be okay. So USDC is mainly done by Circle, which is this company that deposit $1 and creates a dollar on chain. And if you go into the Circle addresses, you can find in the, of course, in the testnet tab. You can look for it, and you can just protect the contract address from here. And let me just quickly, do we have like a chat in here?
I just shared it in the Telegram group.
What?
I just shared the.
Okay, thank you. Okay, so so we don't have a constructor yet. So before the functions in here, we can write constructor, and we can leave this empty because no, not really. Address, we can pass an address, and we can type like USDC address, and we can open up the constructor and say that ERC20, USDC will be equal to ERC20, and we open up the parentheses, so ERC20 at this address, and you can, we can either like hard code that way, but since we are using this in construction, we will use this particular address from the script that we use to deploy the contract. We will do that later. In that case, we can just write USDC address, and okay, let me just comment this that way, so I can easily find it later. Okay, so from now on, every time we call USDC, we can find all the contract functions from the USDC. Yeah, need me to scroll. Okay, so in that case, in here, as we saw yesterday, we can use transfer from. So we can easily access the USDC contract interface from USDC, and we can write transfer from. So what we want to do is like to use this contract as an escrow, as a deposit contract. So we can just write transfer from the message sender, because we want to take the money from the sender that is calling this function. It's not like the user sent us the money. It's the contract that takes the money from the user and transfer the money to this contract. So we use address this. And of course, the amount in will be the value that we need to transfer. Before doing a call to this contract, it will be very hard, very important to remember to give approval to this contract to transfer the money. Otherwise, the function will be reverting, and you may, depending on the contract that you are using, in particular, you may figure out immediately or not. So always remember, if you get like the function reverted for no reason, and you struggle to figure out why, always think about, did I get the approval? So important, give approval to the contract. Okay. So we are not making any requirement now. If you remember, we did like an error campaign doesn't exist, and this will prevent any user to mistakenly doing some funding to a campaign that doesn't exist. So the first thing that we did here is to declare the campaign, but maybe as soon as we read from the campaign, we want to use what is inside to figure out if the campaign is currently initialized. And since an object is like declared with 0 values, we can simply like make a check and tell like campaign if campaign and what would you use in here? Like you can use pretty much anything. So for example, we can take the expiration date, and we can like say that
if we are close to the expiration date.
Yeah, we could just make double checks, like figure out if one of those is empty, apart from maybe amount raised. But if it doesn't have a creator or a description or whatever, this object doesn't exist. But since it has always also like an expiration date, maybe we can like merge these two things. It's up to you. Like, any suggestion how any one of you will do that?
I think it's cool to check if it's expired and if it exists at the same time. So it's just one check.
Yep. So how would you write like campaign expiration date? So that's pretty easy. If block, remember.
Dot timestamp.
Okay, dot timestamp is currently greater than the expiration date. Then we can revert and revert with this error that we created using campaign ID. Okay, so sorry, okay, let me do that way. Okay, I think it should go. So let's see if I made some mistake around, which is very possible because okay, campaign doesn't exist. Of course, because we wrote this outside, so we need to inherit this interface. So we can simply write I crowdfunding platform, and now the contract should compile. Okay, so we are checking if the campaign exists. What else could we do? I think that's just fine. No? Not sure. Do you see anything else I can like write in this contribute function, in your opinion?
Depends on the properties. Can I see the properties for the campaign?
Oh, sure. Yeah, the status. Okay, then. No, I think the suggestion from. I think that we are pretty much okay. I'm not sure about it because we will check later, but I think it's fine. We have pretty much everything. We are updating the amount in. We are updating the campaign, and we are like taking note that the user.
You can check if we satisfy the goal.
Oh yeah, sure. Like if we already have surpassed the goal, we can maybe we could do that. So in that case, we will write another error maybe. Campaign goal achieved already. Campaign ID. Okay, so if the oops. If campaign status equals campaign status completed, we can revert with how did I call that? Goal keyword ready, campaign ID. Okay, and maybe we want to like I'm not sure about how I want to do now. For now, let's keep things simple because if you like, let's say that there are just $2 to the goal and you are depositing 100, maybe we should like refund the other one. For now, just keep it simple. Maybe we can do that later with the checks, but if we can check after the deposit that if amount campaign amount raised is equal or greater than campaign goal, then we can set this campaign status equal campaign campaign status dot completed. All right, and so we can do something like that. Of course, we need to to update the campaign letter after that, and maybe we can set the transfer from later in here. So that's pretty much it, I guess. Let's see if I left some error. Let's build, and of course I did some error. Line 75, of course, okay, and that's successful. So that's pretty much the two main functions that we have in here. Maybe now we can write a function to withdraw once we are once the campaign is completed. No, so we call that function withdraw, and of course we write the campaign ID, and we don't need anything else in here, but I can introduce you to modifiers. So modifiers are functions modifiers are something that you write like next to the visibility scope, that are like conditions that you could you could write inside the code or the function external. To be clear, you could start writing in here, but you can make some kind of function that is reusable. So let's see how it works. Like, for example, I can write a modifier in here, modifier, and call it only creator. So we want to create a modifier that lets only the creator will be able to call this function. So we can even give an argument in that, like for example, creator. We could pass like I guess the campaign ID. That's not really something that is necessary. It's just to show that we have this modifier stuff in here. So the first thing that we write in a modifier is underscore and come si dice? Come virgola, semicolon. Okay. And then in here we could write something similar to that, taking the campaign object in here, or even accessing the campaign directly, like campaign. No, sorry, as campaigns, campaign ID, creator. Why doesn't creator? Okay. And sorry, maybe we want to do like a check, require as campaign is equal to message sender. Otherwise, not only not creator. Okay, so this should just check if the creator is able to call this function to withdraw. So now that we have a modifier, we can write in here only creator, and we can pass in here the campaign ID. Of course, to check that I didn't make any mistake, I can build in here, and that's successful. This is something that in this particular function, it's like an overkill. But if you have a lot of function in which you are doing the same check over and over, maybe using a modifier is something that helps you not repeating yourself a lot. In that case, we just need one-time check. We could have wrote this directly in the functions, but you can use modifiers to save some time and improve readability of the functions. So the first thing that we want to check is maybe to create. Let me write the error in here maybe, and then I'll put it on the interface. Error not completed. Unit campaign ID. And the first thing that we want to do in here is to again initialize the campaign object. But maybe at this point we can even use the storage one, because we are not necessarily doing too much stuff, I guess. We may actually want, now that I think about it, maybe we want to add fourth one, like claimed, I guess, if we already claimed this. Okay, I don't think I need to change anything somewhere. Okay. So, for example, in here, we can tell that okay, campaigns equals to campaign ID. Okay, and we can if campaign status. Okay, we can like check both things, like if campaign status is not, or maybe what we could do, like campaign status is failed, or failed means like the time isn't expired, like the goal is not achieved and the time is not is expired. So to do so in reality, I think we should somehow store the failed stuff in some different way. And the way we could do that is maybe through some view rather than writing on the storage. So the first thing we could just write if campaign ceased campaign status claimed revert with okay, error already claimed. Okay, already claimed. Okay, but since we don't have like a way, like for example in here, how do we track that? How would you like tell that a campaign is failed? You are not going to write on chain just this. Like if you have the campaign that is actually expired, you don't want to write on the code, right? Because it's just wasted gas. Basically, you are creating a transaction just to sign that the campaign is reverted, basically. So how would you possibly do? Any idea?
So what you want to do is to check if the campaign is failed.
Mm-hmm. Yeah, I mean, I created the failed status, but it's not something that is necessary, maybe.
Maybe we can use a modifier just like we did with the check for the creator. We can use a modifier like we did for the creator and check in the modifier is expired or like the
Yeah, we could do that. Generally speaking, like yes, you can do that, of course. But generally speaking, modifiers are used mainly for like mostly for access or some to the functions. Who can access the function? It's not a rule it's not like you cannot do. Generally speaking, people tends to write the access to a function in here or modifier of this way. Yes, we could do that way. We could just there are many ways to do. There is not like just one, I guess. Okay. For example, we could like just like compare to the timestamp, basically. Check if the expiration is passed and the amount was. But yeah, we can also like create an internal function. Let's do that way. For example, we can we could like is expired. And we could pass directly in on int expiration, int goal, and int and int what was the amount raised, and this may be an internal function, internal view function, and we can just like tell that this does returns bool is expired, no, is failed. Sorry guys, is failed. Is failed. Okay. So one thing that you can do when returning the functions, when you have functions that have a return, you can do two different things. You can either like write bool is failed that way. So if you write that way, is failed already exists right now. So you don't have to redeclare its type. that way, or you can just return a bool and create like bool is failed. And there are a couple ways to like do this stuff, and basically it's up to you. There is no better way to write that. I generally prefer writing in here, so it's more clear. So you don't have necessarily to write that way anyway. So it's failed is accomplished if block dot timestamp is greater than expiration and goal is greater or equal. Is goal amount raised is lesser than the goal, right? If it is like we could just return that way, I guess. Like this will return a boolean, and I think it's correct. Yep. So we can call internal functions from here. Like that's something there is no general rule on how you handle the function. Also, in that case, it's up to you. If you happen to use a lot this is failed function, you better write it in here. Otherwise, there is no problem in writing in that. But generally speaking, breaking things apart and having internal functions may be something that you want to look into if you want to optimize the gas in your contract, because what is happening inside the internal function does cost a little bit less than what is happening in public and external specifically. So a lot of optimizations comes with breaking things in a smart way. So in that case, we created. We didn't create campaign failed. Campaign ID. Okay. So we can write if is failed. Oh, yes, is failed, and we can pass, since we are now using this function and we are accessing all of this information. At this point, it's better to use like memory, also because we are not doing that much changes. So we can just pass the campaign expiration date, campaign goal, and campaign amount raised. Okay, sorry guys that the readability is, I wish I had like a larger screen. I don't know if I can see it that way. Okay, so we did pretty much everything in here. The last thing that we want to do is to actually set that campaign as campaign amount, not amount raised, status will be campaign campaign status, and we set this as claimed. Okay. Okay. So the last thing that we want to do now is to give the money to the creator at this point. And the difference in here from what we did on top is that in here we don't need to use the transfer from, and if we try to do so, the function does revert. It's a little bit non-intuitive, but transfer from doesn't allow like yourself to be the from. So if you want to transfer from this contract that is holding the funds, you rather call just transfer. Okay. So that's for direct transfer. So we may actually want to call, we can either it doesn't really matter if we use the campaign or the message sender, but reading from the message sender is cheaper, so we use message sender. And the amount that we pass in is the amount raised. Okay. So we have pretty much everything. We can put this one in here maybe, and now we want to maybe create some event to emit when the functions are called. So let me just forge build very quickly. Expected primary expression. Oh yeah, of course. Sorry. Line 95. I forgot to write what to do. Revert. What was the name? Naja. Campaign failed. Okay. Campaign failed. And campaign ID. Okay. So now if I compile, it should be fine. Nope. 103. 203. Okay. The current syntax for that is I forgot the returns. So when we do a view function, we write returns, and we return with return without the S. That's it. I think like I have some problem with my extension in here. If you do that kind of things, this kind of mistakes in Remix, they get underlined. Maybe for you it's working. I don't know why it doesn't for me. But okay, forge build it again. And what else? Campaign, campaign status, storage ref, status not found or not visible argument. Let me just quick look at it. It's 99. Claim doesn't exist. Campaign status. Isn't it right? Campaign status. Status. Campaign. Oh. Status equals. Sorry, guys. Having like campaign status is claimed. Reclaimed. Status. What's wrong with that? Like campaign. Isn't it working? The fuck? Sorry, let me quickly ask my companion in here. I don't quite get what is telling me. Should be a stupid mistake. Let's see. Didn't write it that way. Okay. Okay, it was a stupid mistake. I forgot those ones, I guess. All right. What else we can do now? We were doing the events. So if we write like, we mainly have like 3 events to write in. So one is campaign created, and we can add like, we can just use the campaign object, I guess. Like we could use maybe an identifier campaign ID and index this one. So we can index at this one, and maybe we can also like have campaign memory, if I'm not wrong. Campaign. So in the event, all the information about the campaign will be easy to retrieve. Not sure about memory, no, indeed. It doesn't need the... it doesn't like campaign, maybe from some... Okay, let's just write the campaign that way. Campaign ID. And, okay, maybe we can have all the creator, title, description, okay. Event, contributor, okay. The AI is doing all the events for us. Maybe claimed and failed, we don't need those. And of course, in each one of this function, once they are completed, we can emit whatever they do. So it was contribution, this was emit campaign created, and that one is emit withdrawal. Okay, so give a fast compile in here, and I think we have pretty much everything. You think anything else that we can maybe possibly do? Like, for example, we can make a function to do multiple campaigns, like not maybe creating, but maybe you want to contribute to more than just one campaign. Otherwise, the one thing that is important about to understand about transactions is that every time, let's take a random transaction from the block explorer. Okay, if you go and to inspect a transaction, you will always find those information. Have you seen that with Fabrizio 2 days ago? Okay. So the gas is the measure that like describes how many opcodes operations has been performed, how much is their cost, and they are expressed in giga way. And if you go to like converter, a way, do you know what is a way?
Fraction of the S, right?
Yeah, so basically Ethereum by itself, 1 Ether is 1 and 18 zeros way. So way is the most the tiniest unit, and gigaway is a little bit more. It's like few. I think it's 8 zero less. It's like 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should be like 8 in reality. So 1, 0 and 8 zeros. And that's the measure of the cost of 1 unit of gas. So if your function as you can see, like there is a gas limit and gas usage. This function used that much gas units, and that is multiplied for the cost that is assigned to you. So the more the gas usage, the more is the cost, and the cost of a unit of gas depends on the congestion of the network. So if there are no transaction, it will be minimum. If it's very congested, you will going to pay a lot. And this is especially true on Ethereum. That's why people, especially users, use layer 2, because layer 2 is a network which is batching a lot of transaction and saying, okay, I've done 100 transaction, and it just posts one transaction to the layer 1. So you save gas and a lot of money for end users. So that's the Ben said that this is very important. If you take a look at this function, on 126 is very okay as gas price. Is not at that high, but the very important thing that you need to notice is that every time you send a transaction, you have a sort of base cost. There is like a minimum gas usage that the transaction will produce just to create the transaction and for the validators to take it in. So if I'm sending like 2 times the deposit function to fund someone, it would be smarter to just like have one with bigger input, but save on the base cost of the transactions. This is something that on a layer 2 is not very that important, because the cost is very cheap on base. For example, the cost of the transaction is like fraction of cents. So like it's not much about the cost itself. It's more like maybe about the user experience, because now we have don't want to put too much stuff in it, but if you are going to like sign for multiple transactions over and over, the user experience is going to be tedious. You would rather not interact with the application at the end. So one thing that we can actually do to make it more usable is that we can wrap the function that we already made. Maybe we can just do that for contribute. Maybe it makes sense to make this for withdrawal as well, or for the other one. But let's try to make contribute first. So we can call this function batch contribute, and okay, the AI is suggesting stuff for us. We would use how do I delete this? Okay, we can just use the array. As I told you yesterday, remember that we need either to call with memory or with call data. For now, avoid call data, because like there is it's a little bit hard to convert call data and make use of it in the functions. If you then need to maybe convert to memory, is a little bit hard to handle. So for now, just try to stick with memory, because call data is something that you may use later if you keep developing in here. So what? Sorry, wait a second. Okay, foundry build. I think there is some error. No. Okay, no. So we simply can create this function and create a for cycle to use that, and it's very similar to other language. There is nothing like crazy with it. we can like declare variable I, and for like let's say e less than campaign IDs dot length e plus plus or plus plus e. Okay, and for each one of these we can call function contribute, and we pass in is I amount in amounts. Okay, so that way we just call every function with the amount that we want for each of the campaign that we selected. We may have a lot. Of course, if we are like contributing to 100, we are going to pay this a lot, because each time the default cycle calls the function, it adds up on the gas cost. But that's probably not important, because I don't think that people is going to abuse that function that much. Of course, each time the transfer from will be used from the outside, like before doing that, you need to make like from the front end or from a script in general. Before calling this function, you gotta sum up all the amounts. Otherwise, it will just failed. So you give approval to make sure all the transfer from are going to work. And now it's a little bit not necessary, but you may also want to like know if now we have like where is the shot? Can you see that? Where is the shot with the guys, bro? Whatever. Okay, you can go in Solidity by example, because we don't have time to watch every of these concept. But this is a very well done, it's very comprehensive. It has pretty much all the rules in Solidity that you may need. And this, I will link that later, but you can just Google for Solidity by example. And this is it has pretty much everything. And the thing that I was saying is that you may want to use, for example, try catch. So you have this function and you are executing function. If one doesn't go through, you don't revert the whole thing. You just revert this particular one. And try catch is pretty much the same as the other languages. It has only few difference. For example, try catch may be used only on external function. You cannot use try catch into an internal function of the contract. It's generally something that is not that used in Solidity, because it has quite a lot of gas cost, and by design people just choose to not use them. But you can already know that it exists. And of course, if you also want to have more advanced knowledge about other things that are available as what you can use by default in Solidity, these are there are pretty much everything. There is also assembly stuff, because in Solidity we can eventually, I don't know if you are like familiar with assembly code, but you can do operation with assembly in Solidity, and it's generally some advanced topic. But if you are familiar with assembly already, you might find this interesting. And okay, if you scroll that down, there are couples also interesting hacks that like are useful to like figure out some cool trick to like make hacks to or to better say avoid getting hacked in a contract. And there are also some tutorial that may be useful for the hackathon if you need to. We can maybe look one of those later if we have time. But if you, I will be into during the hackathon, so you are free to ask. But in here there are some example about swapping tokens in Uniswap and getting the price feed from Chainlink. I don't know how many of you are like confident on what Uniswap is. Uniswap in general. Okay. Okay. Before going to code something more, maybe we should talk about it. So Uniswap, it's one of the most used protocol in the whole Web3, together with Aave, which is another decentralized finance protocol. Decentralized finance is one of the main use cases of the blockchain. Like this protocol now they hold billions of dollars, and they are generally very, very safe. They are audited by the best developers in the industry. And Uniswap, since I think that the hackathon, I'm not sure about what the hackathon is about exactly. And let me check if they. But I read that there is like a track with decentralized finance. So you may want to know that there are, for example, Uniswap. Uniswap is simply a website in which you can go in and you can like log. I'm not sure. I need to go to the testnet maybe. And what you can do in here is basically exchanging values. So, for example, now I have 0.66 ethers, and let's say that I want to buy USDC, and okay, this is the testnet, so many of these are just tokens for testing purpose. And I can simply go, for example, in here and put like a tiny amount, in that case like 0.02, and it tells me how much is the conversion. I can just sign in. It will ask me to make a transaction to send my money to the contract, so that the contract can make the swap. And once it's completed, it should be okay. Now I should, if I refresh this, maybe I should be having some USDC. Okay. This is okay. And now I have 147 USDC. That's something that you will probably do a lot in the blockchain field, because there are many applications revolve around money, no? And not only on all the application, but a lot of those are revolving around finance. So there are protocols like Uniswap or lending protocols that may be useful to build application for any use case. For example, to make an example, in Bucharest during an hackathon, I made this TaxMate application. It was an application for like companies to invest the stable coins to earn some interest, like you will do with your money in the bank. Very simple, through not with Uniswap, but with Aave, which is a protocol that is for lending. Like you can borrow money and borrow and lend the money. And we made this application that exported your income stuff, and was ready like to be given to your accountant, commercialista. So application of this kind are doable, and you may find some example on how they work here. For example, like this is an example of how you do an exchange on Uniswap, or how do you read the price of Ethereum or other currency in the blockchain. All right, so little parenthesis in here. Do you guys want to make a quick pause before we go into the test phase? Okay. If you have any questions, sorry, I've been speaking a lot. If you have any question, feel free to make them.
Is it possible to share these icons to put tracking?
Oh yeah, sure. Okay. We'll go quickly to the bathroom, and maybe I can initialize GitHub repo so you can pull that. Okay. Sure. Okay. I guess like we can make like 5-minute breaks. Of course, this is not the owner. Okay, let's start over. Since I already wanted to show you also ERC 721, which is a different kind of token. And like yesterday we spoke about ERC20 being fungible. That means that there is no difference between one token and one from the same address. They all equals like euros are fungible. But there are other kinds of token that are used in a different way, and they also are referred as NFT, non-fungible tokens. And these are just mostly used for collectibles or maybe for just attestation and many other use cases. But it's pretty much the same interaction that you have with this token, but they share different little differences. So what we can do in here to just make use of it is not something like the best use case, but we can use in that so you understand how do they work. Is that let's say if you contributed some amount into a campaign, maybe you can get an NFT to show that you contributed to a campaign. Let's say, like now maybe we can add a new attribute into the campaign. Let's say minimum for NFT. And if we make this, we need to update whenever we are using that object in here. Maybe we can update the function signature to have a minimum amount of USDC to send to unlock this NFT. So we can use underscore minimum amount for NFT. Let me just quickly compile to figure out if everything is good. Okay. And what do we want to do now is that we want to import this standard from the OpenZeppelin library. So we can simply write import ERC721 from this path. You can find the token standard in the contracts folder of OpenZeppelin, and it has token, and it has few of them. So in that case, we use 721 for this purpose. So if we are importing not the interface, but the contract itself, we need to do a couple things to configure this NFT. So the first thing is that we want to inherit. So we have all the function of the NFT in this contract that we are creating. We could do differently and have like this contract control the NFT contract, or we can inherit, so they are the same thing. In that case, we can simply write is ERC, sorry, not here, this is the interface, and we write it here in the contract, not in the interface. Okay. So now that we have created this, we imported this, let's take a quick look at the contract. Okay. The contract is an abstract contract. It has a bunch of other imports. For now, don't care about them. Just let's take a look. they have mapping that maps a special token ID to an address, because the NFT token, of course, is like let's think about like it is a digital card, for example. There is one card and one user that owns that card, for example, and another bunch of other mappings that are the approvals and the operator approvals, which means like this is happening under the hood also in the ERC20 token. Like you have to store somewhere how much the approvals are. Pretty straightforward, but it has a constructor, and the constructor initializes the name of the collection and its symbol. So generally speaking, the symbol is like just an identifier of your choice, the name as well, and then there are a bunch of functions that you can use, like if you have a particular ID, you can retrieve the token address, the token owner, function to retrieve the name, the symbol, and token URI, because NFT are also used to store metadata. And for example, we can go in OpenSea, which is a very common, very used marketplace for NFTs. You can go in their website, and you can use this website to buy or sell NFTs on the market. And this is actually how an NFT works, like how it looks like for example, Discover. I don't know, collector mode. Sorry, there is like a tutorial. What the hell? Okay. And okay, that's a very, very, very crypto thing. People is generally degenerate, spend a lot of money for NFTs for some reason. Some may be useful, some may be less useful. But here, for example, there is a collection. So all the objects that you see in here are part of the same smart contract. Like here, there is an ERC20 token, which has the name CryptoPunks, and every token has basically in its metadata a pointer to what is the image associated with that one. So as you can see, every one is different, and it's like collecting cards or whatever. This is a very famous one, very costly, as you can see. But let's click on one of those, and you can see that this object has some data in it, like some traits, like for example the color of the hairs and whatever. And these are all information that are basically held into a storage slot in the contract. So every NFT has its own token URI, which is basically a JSON file, might be a JSON file that store, for example, the link of the image that it displays, some attributes, something that is relevant to the use of the NFT itself. So that's the function to retrieve the public, the URI for a given token ID. And of course, we have all the functions that we saw already, like transfer and a couple difference, but it's generally the same thing. So since we saw that this contract has got a constructor, when we inherit the contract, when we inherit a contract that needs to be initialized from the outer contract, we need to declare what are the arguments we need to pass to its constructor. So in that case, we want to initialize, we want to create some more argument like string memory, name, symbol, etc., as you can see. And we want to use those to be passed to the contract that we inherit. So we use it's pretty simple. We're using the name and symbol on the ERC20 contract. So when we are going to deploy this contract, all the functions that are available in the contract below will be basically available to us. And exactly how we did yesterday with the mint function of the ERC20, if we go and check if it has a mint function, like function mint, it doesn't have this one, but it does have an internal one, which is _mint. And we can basically use that because this function is internal, but it is available on the outer contract. So we can create a function from the main contract in here that means the token ID to the user. So one thing that we need to make ourselves is like creating another counter, maybe NFT counter. And what we want to do is, if we go below in here, we can where is the function in which we contribute? Okay, that one. Okay, so in here, if the transfer is sorry, okay, if the transfer campaign if amount in is equal or greater than the campaign minimum, how did I call that? Minimum for NFT. Then we can call this mint function, and what it does ask to us is to who we want to mint. So in that case, the message sender and the token ID. Since we are creating like incrementing each time, it's safe to use the actual message sender, the actual counter that we just did, which was an NFT counter, maybe. Sorry, I have a very bad memory. Like I keep forgetting things. Okay. NFT counter. So that's pretty simple. If now our user pays above the maximum, the contract will create this NFT for us, and it will be available for us. Of course, something that I'm not sure about, like ownable. Okay. Let me see very quickly this implementation, because I don't think he does. Okay. Yep. Okay. Okay, something that this actual contract doesn't have by default, but it's a general rule that that you may apply to an NFT is that in that case we don't need to like have like she was asking an owner for this particular contract, because we don't expose the mint functions by itself. Like we have these internal functions that gets called whenever you pay more than the amount set. But and so no one is able to call mint function outside of this rule that we made, basically. But if we were to like be the person that has, for example, a custom let's say that you want to mint by yourself for your user, you may use modifiers. For example, like let's say we have a mint function that takes like address to and mint token ID public, and it does mint to and token ID. Everyone will be able to call this function, and so the value of the NFTs will be lost, because if we go in this collection has a value because like the supply of tokens that are available for people is limited. So like I think this one is capped to 1,000, I guess, but whatever. So when you are the owner of like a project that creates NFTs for your user, it's a good practice to be the owner, and you can generally use. You can either write that by yourself. It's pretty much something very easy to do. You declare an address owner, and during construction you pass an address that is supposed to be the owner. Or you can also use import ownable, and ownable is basically a contract by OpenZeppelin that lets you set who is the owner in that way. You just declare ownable, in that case the message sender, so who is deploying the contract. As soon as you do that, you will be able to have like only owner modifier. So just the owner can now call this function to arbitrarily mint to other people. That's just for example. In that case, for the campaign, it doesn't really matter. But just in order to let you know, there are these possibilities. So if you also with the ERC20, if you are doing your ERC20, you should also think about who can access the function, let's say for creating tokens. Otherwise people will create tokens out of nowhere. Is generally a good practice to not allow the supply to be managed even for the developer, basically. Let's quickly forge build, and this not identifier not which what is the problem? Okay, let's comment out this for now. I will check it later. Oh, because maybe let me just revert this. I think I fucked up somehow. Okay, now we simply added this ERC20 token. Of course, when if now we try to send a transaction, this by default under the hood has all the events, and this is true also for ERC20. So if you launch a transaction, let's say the contribute transaction, from the block explorer, you will be able to see every transfer occurring. So the transfer from you to the contract about the money, maybe the contract means you the NFT back because you've been given enough in order to mint, and that is so now maybe it's time to try to integrate with the blockchain. So we can do many things in here. Now I show you a few comments that are up to you to use. One thing that you can do if you don't feel comfortable with a framework like Foundry and want to play with the contract, you may just take this stuff and put it on Remix. Let's see if it does work. If it doesn't, I give you a command to make it work just as fine. Let's try this one maybe. Okay, it cries because of the Solidity compiler being different, like 28. Okay, so that's pretty much like ready to be deployed or used. If you have any problem figuring out things, you can just go in there and in the deploy tab you just can fill all the things that like the USDC address, the name of the NFT and its symbol. Just deploy it and then play by yourself. But the whole campus revolves around the use of the Build Guild framework, which is a tool that auto-generates front-end stuff, a lot similar to the buttons that you get out from Remix. So you will need I think for the hackathon we have a bounty with the Build Guild. So you better figuring out how to make the deployments and the stuff in Foundry so you can easily work with that. So the next thing that we want to do, since the contract is ready to be deployed, is to create a script. I don't know if, yep, that one, let's delete this one for now. And maybe let me just crowdfunding, let me just rename this and rename this crowdfund deployer. Okay. So the deployer script is what we will need to use to deploy this contract to the base network. So now the import is wrong, I guess. We just need to modify that. We can uncomment this very quickly. And so basically, we have this folder, which is the folder in which Foundry expects the scripts to be, and you can see that it is inheriting some file from the. Do you want me to enlarge the screen, or it's okay? Okay. So there are a few libraries that are getting imported into this. You don't have to care much about that. So that's something that you want to do. Maybe is to update the initial contract in here, crowdfunding platform, and okay. So what it does is basically that script expect these two functions to be in the script to work. So in the function setup, we can set up what contract we want to create, and in contract run, we can actually write more logic and just make those transactions that we do in Solidity be broadcasted on the blockchain. So in this very little example, this in the default example would just deploy the counter contract, and whatever you wrap between start broadcast and stop broadcast are the functions that are really broadcasted to the blockchain. So if I'm not wrong, somewhere in here I should have the USDC contract address that I already initialized, and we can do how we prefer. Like, for example, we could just hard code the value in here, and we could give like a name to the NFT, like loyalty NFT, whatever. You choose the no, that's the symbol. GRBD. You choose the name. Like, there is no actual restriction on that. We can leave the setup information empty, and since we are not dealing with counter anymore, we can just crowdfund platform, and we can deploy a new contract, USDC name and symbol. Okay. So if we now run this with forge script, and then we need to give the location script of the file, so deployer.s.sol, and due punti, and the name of the contract, which was exactly, let me check, okay, crowdfunding platform. This won't itself, I couldn't find, oh, no, sorry, I'm just an idiot. Deployer, we need to use the name of the script, not the contract, of course. Okay, this will start to compile, and it will just tell that everything is simulated in this script was correctly compiled and executed. But we haven't broadcasted the transaction. To do so, we need to have somehow our private keys, and there are many ways you can do. Like, if you are like deploying from here, for example, this very contract, hello, you don't have to like put your private key anywhere if you are injecting your provider like that and transacting, because MetaMask will be prompted, you will sign the transaction, and in couple of seconds you will be able to see the transaction, the contract creation transaction. But this is happening because MetaMask already owns the private key internally, and so that is a way in which you don't need to like keep your like put out your private key in some way. But there are many like for using a build guild, maybe you will be needed to like deploy from either Ardat or Foundry, one of those two frameworks. So what you need to do basically is like to export the private key, and that's actually like a delicate moment. You are not supposed to like handle carelessly your private keys, like you're not supposed to like paste them like in chats with your teammates during the hackathon. I mean, if it is a private key that you just use for testing purpose, it doesn't really matter. but you should be always like keep in mind that maybe you should like delete the account after the hackathon or whatever, and always keep in mind that your private key is the only thing that someone else needs to control completely your address. So you need to care to manage this very carefully. For example, now I am streaming my whole my private key basically because we are live, but fortunately this private key is very useless. I think maybe I can use this one that is surely never used. Or if you don't have like initialize your MetaMask account and don't want to, Foundry has a very cool stuff in here, which is Anvil, which is a local blockchain that you can use for testing. And Anvil comes with a set of if you just write Anvil, it's installed along with the Foundry. It initializes a blockchain that is listening to this port, so you can broadcast, you can make a faster test on your local chain, and it comes with a bunch of private keys and their relative accounts. For example, let's take maybe this one. You can also export from here. Let's try that way. It's okay. It's up to you. Depending on the necessity, this is a fast way to generate a lot of private keys. Show private key. You are asked to input the password you set with your wallet, and boom! Now my private key is everywhere in the web. One may think yeah, it's not going to happen to me, but this very little moment might be, this key might be already compromised, basically. So a good way to do to handle your private key in Foundry is through key stores. You are not supposed to set. I mean, you can do that, but it's generally not a good practice to have your environment like you will do in other context. Foundry comes with a very easy to use tool, and the command is pretty straightforward. So the command is cast, which is another module that is already installed in your computer if you have Foundry right now. Cast wallet, and I think it's create. No, sorry, import, and we can call this default key and interactive. So I will share this command later. Maybe if you need on the chat, I can share that. So if I now write this command, oh yeah, sure. I already have one of these. Let me just quickly delete this one so I can start fresh. Okay. So now I don't have a wallet. I can press enter, and I'm asked to paste my private key. So I now just hit enter, and it asks me to create a password. It can be a very stupid password, just maybe don't use the same. Let's call this like Bob key, for example. So now the default, if I now navigate in here just to show you how it's okay, that is how my private key is being stored. It is stored not in plain text, it is encrypted in our machine. So if we happen to expose our password, the we are more safe. It's like better than exposing your private key. So now to make like use of this key that we let me just figure out if a wallet is the one I'm supposed to have. Okay, 03D84. That one. So you need to not have the 0x of the private key in front, basically. So now I have this private key stored in my PC, and I can safely use that. And what we can do now is that we can add some information more into this script, because we want to broadcast this transaction. And what we will do is that we can story. Let me just quickly look at it. Count default. Okay. Okay. Account default key, which is the account that we already created. Then it asks us we need to insert -- sender and the address that is going to be the address of the wallet that we imported, basically. It's a little bit annoying, but we need to insert this as well. And then we can set RPC URL, because now we are trying to broadcast the transaction to a blockchain. So we need to find the RPC of the blockchain that we want to deploy on. In that case, you can go on the chainlist.org, and you can choose your favorite your target chain. In that case, I want to deploy on base Sepolia. And if you open up in here, there are a bunch of base Sepolia RPC nodes. I think this is just fine. So we give the link to the Sepolia, and more importantly, we write -- broadcast. So we are giving like the okay to start broadcasting this transaction to the chain. Of course, this will fail now because I think this doesn't have any Sepolia. Okay, so let me quickly send some fun to it. Okay, let's say 0. Is that Sepolia or base Sepolia? Okay, so base Sepolia. Okay. Oh, if you don't have base Sepolia into your network, you can connect wallet, and it should. Now I think I already have this. No, he's asking me anyway. It automatically prompts you to add this network to your MetaMask wallet if you don't find it from here. Just to make a recap on the wallet perspective, here on the top left you have all the network that are available and saved in your local MetaMask. So now let me quickly send some Sepolia ETH in here. Okay, even like a small amount will be just as fine. Okay, so now if we start broadcasting, one more thing that we can add is VVVV. This is the verbosity. So if there are errors while you are deploying, it's like having a trace of what's wrong. You will have like the logs of the transaction, and if there is some error, you will be able to figure out what was the error actually. So broadcast. Okay. And BBB is not okay, just one dash. Okay, so now is just doing some compiling, and he asks us for the key that we previously set. So in that case, I have a Bob key, and the transaction will be broadcasted, and now the contract is deployed on the Sepolia network. And as you can see in here, you have a couple logs about it, like how much gas it costed, and the block is being deployed too. This was the actual gas that we spent, so very cheap. If you take a look at it, it's very, very cheap on base, especially on testnet. And this is the contract hash. So if, sorry, the transaction hash, and this is the contract address. So if you want to check something about it, you can go into sepolia.basescan.org, which is the testnet scan for the base net. If you pass in the transaction hash, you will be able to see a bunch of information about this very transaction. And more importantly, in here, you can notice that we have an actual address that is being deployed in here. It's a little bit slow, but everything went fine. So now we have this is I haven't verified that. Have you talked about verification with Fabrizio, like what you use like a scan in general? No. Okay. So this is a contract that is not verified. It means that we are not able to explore with a good user experience. The contract is still public, basically, but all the information that you can read in here, this is the bytecode that is being deployed. So Solidity code is being interpreted to machine code, and that machine code represents the contract. And we see that way because I haven't verified that contract. If we go, like, for example, in basescan.org, I don't know, like SSG base contract, you will be able to go I don't know, like, sorry, give me a second, let's find a contract, like a token, okay, USDC. If the contract is verified, you will see the green mark in here, and you will be not seeing the bytecode, but you will be seeing all the contract, and more importantly, you can use those tabs to navigate the contract and see, for example, read exposes all the function, the view function that are available into the contract for the user to call, and write the same thing, but for the one that changed the state, such as like external or public contract. And you can even interact with your contract that way. So if you are like in some emergency case, maybe you don't have time to write your own script, you can just use MetaMask to interact with a contract that way. So just keep in mind, maybe you want to quickly read what is the total supply of USDC, and you can quickly read from here. You don't necessarily need to write your own script. So I don't think we have that much time. We can surely talk a little bit about test and like interacting with your function. Like for example, now I have deployed this contract at this address, and we may want to create another script maybe to create a campaign. So like we can create create campaign.s.sol. We can just copy and paste this one, so we have something already in here. And differently, in this very script, we don't need to deploy anymore because the contract is already deployed. But maybe we can write that the crowdfunding platform is equal to crowdfunding platform. I don't want this. Okay, we can. Sorry. Crowdfunding. Let's say like public funding address equals 031. Okay, we can even write this in the environment. I'm just coding to be faster. So since we have already created this contract, we can tell the crowdfunding platform at address crowdfunding address crowdfunding address. Okay, so from now, if we use functions in that one, we are interacting with the contract that we just deployed, and we can get rid of these two. But we may still want to use USDC for later usage, maybe. Not in that case because we are just creating the campaign. Okay, no. Okay, let's do a simple campaign. Let me open up quickly the other code that we wrote. What is the function signature? Okay, so we can simply write in here that crowdfunding platform. Now we expose this public function, so we are able to retrieve this function from that way campaign, and okay, he did randomly. Okay, let me just format this for better readability. Okay, so to recap, we are creating a goal of some number, having some expiration date, but this is very like unreadable. You don't want to like work with hard-coded values in that way. And maybe if you want to like handle big numbers with a lot of zero, something that is more clear to do is either like multiplying 10 by the power of something, or you can write e and the number. This is equal to 1 and 18 zeros, basically. So that's more readable. And another concept that I haven't introduced in the ERC20 token context is that tokens, I have also like a public function to read how much decimals do they own. Generally speaking, everything has 18. Most of the token come with 18. Ethereum, one Ethereum is a 1 and 18 way. And this is generally true for every token apart from stable coins. For some reason, stable coins decided that $1 is equal to 1 A6. I don't know why, but that's the way. So in that case, like the goal is you can write like $100, for example. Maybe you can like for your own understanding, like it's up to you to write like a local some local variable in here and have oops, okay, I write that way. And for dates, since you are dealing with the timestamps and maybe you don't want to every time go into a website and figure out what is the Unix timestamp of tomorrow, we can use very intuitive ways to express dates, which are like we can use this in there, I guess, but we could write in here block timestamp, which is now, plus 1 days. We can even say seconds, minutes, hours. I don't think months, days. Like this campaign is lasting for 1 month, starting from now. And the minimum amount to contribute for the NFT is like, let's say, $2 because we are using USDC. So that is. And if everything looks good, Forge build, we should be able undeclared identifier. I guess this is a typo. Crowdfunding. Okay. Conversion. Okay. That is the problem we spoke about yesterday. The function in here is expecting uint64, but we are passing this stuff, which is by default 256. So the Solidity compiler is pretty much understandable in that way. It just noticed that there is a type mismatch. In that case, we can just cast the type. Oops. Keep changing the layout of the keyboard. uint64, and we open up the parentheses, and that should compile because it casted to uint64. So now if I broadcast this transaction, we will be able to see what is going on. Maybe we can also like create a script that looks exactly like that to buy buy from a campaign. So in that case, we can change the name of the script we are calling, which is a create campaign.s.sol. And remember that the name of the contract is important as well, campaign. And create campaign. And if we now deploy, it will broadcast, sorry. It will just figure out if everything is fine, and we can write the password, which was Bob key, and the transaction will be broadcasted. So now if we go and figure out if something happened, nothing will happen because we don't transfer any money, I guess, in here, no? Or we can just create another script like fun campaign.s.sol. Maybe we can just reuse the code from here. Pretty much. Okay. So now we have a little difference in here because the setup is the same. Maybe we don't want to call this create function, but we want to call the function contribute. So contribute, which takes the campaign ID that we just used So for example, 1, and the amount that we want to put in. Let's say that we want to have also the NFT, and we are inputting like $3, for example, because we set 2, if I remember. And this will fail basically because we haven't gave any approval to transfer funds from what the fuck? Sorry, that was the old script. Let's update this with fun campaign and fun campaign. Okay. Crowd fun platform. Yes, I deleted this. Okay. Could not find target contract. Sorry, give me a second to figure out why. Because I forgot fund campaign. Check the name. Okay. All right. So that is now supposed to give some error. It might be scary at first because this is a small one. It usually can get greater. By the way, you don't get this if you don't write VVVV. You can never write up to 5. The more you write, the more the locks, basically. So yeah, what it's telling us basically, it's very readable. That's why we use errors in the way we did, because we can easily interpret what is not going on. Like amount, it's the allowance. So you can just read this and say, oh fuck, I forgot about giving the approval. So one thing that you want to do before sending the transaction to contribute is to send a transaction to give the approval. In order to do so, we need to import the interface from ERC20 token from open Zeppelin. Okay. And so now we have the interface. We can either declare it. What is doing? What? AI can be messy sometimes. Whatever. So we can write ERC20 in here, and you may want to add the address from USDC that we used. And we can say approve, and the address that we want to approve is crowdfunding address, and we want to approve for the amount that we want to be taken away from us and not more. And so we now can just send the transaction. It will ask again, no. Transfer amount. Of course. It exceeds the balance because I don't have USDC right now. So if you have to work with USDC, you can go in USDC circle faucet, and you have this very intuitive website in which you can request either USDC or EURC. You just paste in your what I'm using this one, I think. You can use that one to receive 10 USDC, and okay, and now it should be working. All right. Okay, so the transaction now is successful. We can take the transaction hash, and we can use that in a block explorer like base Sequoia Basecamp. We passed in the transaction, and on top we can see that there are you can see that there are some transfer in here. No, sorry. This basically this is the transaction of the approval, and as you can see in here, it says that we approve 3 USDC for trade and blah 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 and whatever. So that's the first transaction, but we should have a second one because this is one transaction and this is another one. So this is the actual deposit transaction. We should be able to see that we minted one NFT, and I don't know why it's not showing exactly why it's not shown in here. I guess it's just like the visualization of the stuff. But if you go into the logs, you will be able to see there is a log of the transfer emitted by, this is the address of the USDC. So USDC emitted that event in which the transfer occurred. In fact, that's exactly the value that we sent. So that is pretty much the way you would interact using Foundry with smart contract. This is pretty much the same thing you are going to do, but on TypeScript. The only difference is that from here you have much more tools to debug what is not working. For example, not always it's not guaranteed that every time you have an error you have something readable like that when working from the front end, but the fact that you have all the history of what happened during a transaction in here makes more easy to figure out at what point of your code it broke. So that's a little thing, and of course, now that we talked about some of this script to interact and send transactions to the blockchain, we can quickly jump into the. I mean, in reality, we could use this as well as a. Okay, no, let's make it. Let's make a test. Crowdfunding.t.sol, and we can let's do something like that. I deleted the test contract, but it's pretty much the same. Test crowdfunding is, in that case, it's test. Let me fork build to make sure it's working. Okay. Pretty much the same thing in the test. We can import, for example, this contract in here, and what else? Like this. Okay. And the test is very similar to the script. Like you have a setup function to be initialized. Otherwise, it won't understand what we are doing. And now, for example, I want to read any of the functions that we have in here, and to do so, we could create like a function test. Like we literally always need to have a test before each name of a function. Like test. We can write the whole logic, but we can use this also to quickly make the read on the contract. For example, we have let's say let's say that test read counter, and since counter I guess is public, or maybe we can read campaigns. Yeah, read campaigns. We can call this public, and we can simply call crowdfunding platform as campaigns, and we pass as a, since the Solidity compiler auto-generates getters from for public values, but also for mappings. We can pass an argument to the mappings rather than having into the square brackets that we usually do. If we are calling the function, the getter function, to read from it, in that case, we will have this as campaign, and we can pass index 1 because we just created one, and this should return like, for example, the campaign ID. We can like for example, we want to read the amount raised, so we can write event amount raised is equal to campaign S, and since we are returning a campaign object, we are safe to write dot and amount raised, and okay, and then we can just console log uint amount raised. That should work, I guess. Let's forge build. No, I meant literally this one. Sorry, give me a second. Doesn't like it. Let's ask AI. It should work. I don't get why. So something that is different by the forge script is that we don't need any private key to read. Like it's just I don't see any difference. Like maybe it's a typo. Let's try. One phrase not visible. Okay. Maybe we should have done. We should have done that way. We should have crowd funding platform dot the name of the struct, which is campaign. Campaign memory campaign is equal to this contract dot s. We could not access this way. Sorry, let me just quickly make it okay. Console log. Let me just delete this for now. Forge build. Type address is not. Oh yeah, sure. No, why isn't it working? Sorry, guys, I have a little bit of confusion right now. You spot any way it's not working? I don't know why. Different number of left hands. Oh, yeah. It's too tiny for me. What is the as campaign? You should retrieve the campaign. I don't know why it's not working, guys. Sorry. Let me ask AI to be faster so I don't get you bored while waiting. Okay, whenever like I get these errors doing the lesson, I get confused.
That is for the testing part, right?
Yep.
Okay. So you have not set up a GitHub, so I can maybe help us about that.
Oh yeah, sure. Let me just like ask AI rapidly. I need to like push. Working. I'm pretty sure it should work. I don't know why he's asking me because I think like yeah, they should have made a getter because as you can see, like the left hand side one because I'm expecting it to be the type struct campaign and I'm expecting just one object, but on the other side is unwrapping everything and is returning the whole 8 object. So okay, that is the way I should do basically. If I like just accept because it's correct, I guess. Rather than having just one object, it's unwrap everything basically. So like maybe I don't want to ask the assertion. Let me just forge build. Hello? Okay. Yep, a lot of warnings, but you get the point. So that was the way. You just need, if you return a struct, you need to write that way. If you don't care about some of those variables, like the creator, you can just empty that way and just go for the one you want. Like as long as you keep the commas, like. If you just want to read, for example, the amount raised and don't bother writing by yourself, you int there. This way is also okay. It does work. But let's restore them quickly. And then you can like use the standard console log, which is a little bit different from console log in general. You don't just console log and write whatever you want. There is basically a console log for each type. For in that case, I want to console log uint, and I will need to do that way. If you go into the Foundry book, there is like all the list of the stuff. Foundry book for reference. If you write Foundry book, is the website in which you installed Foundry. They have the documentation with all the commands and the stuff that you need, both in the test, in the script, or by console. So now if I forge test, I can, since I deployed this very contract on the Sepolia network, I can call this with the -- fork URL, and we add https sepolia.base.org in that case, so the link of the RPC that we are using, and www to get the console logs. Yes, I want raised. Okay. So what it does is basically it takes the last state of the chain that we are forking. It's putting it on local side and running test against it. And as you can see, we read that this variable is actually correct. Of course, this is very simple test, but in general, you can make maybe more file tests, subdivide them, and in the meanwhile, when you are developing a smart contract, the more it's complex, the more you will need to test to find edge cases. And so this is a good way to not waste much time, because if you go by hand in Remix, at first it may be simpler to figure out if something it would be faster to check the value if I just deploy the near. It would be just one button, but maybe you have some flow to reproduce every time before some test, and this will be much more faster than each time deploying by hand and setting stuff maybe in here manually and whatever. So that's pretty much it. Now, if I have I think we are running out of time. Luca, we have to go.
Yeah.
Okay. Okay, let me just quickly git commit push. Well, with 0.09 and git push. Okay, and okay. Let me just unplug this, and I will share now the